Hey, all, let's get started. Welcome everybody to another webinar hosted by Toad. Today we'll be talking about AWS Recognition and a recent hackathon project that utilized it as a case study. Covering these topics today, I have with me software engineer from Toad, Annie Gonçalves, and myself. Hi, I'm David Dolan. I'm an engineering team lead with Toad. So today's agenda, I'll give a quick intro to Toad and some upcoming events. After, we'll talk about recognition and what it does. Then I'll hand things over to Annie to walk us through how her and her team built out a facial analysis application for a company hackathon. And then we can close out talking about POC funding opportunities in AWS and any follow-up questions. Okay, so Toad is a full-service cloud consultancy. As an AWS Advanced Partner, we've worked with many customers like Daimler, Siemens Gamesa, and Claviet to solve complex data analytics and ML problems. Beyond our data solutions catalog, we also consistently deliver and support consumer-facing applications for industry leaders like the Grammys, DC Comics, ABC, Wheel of Fortune, and a whole lot more. So before we dive in, let's just take a look at some upcoming events. It looks like we've just got slated for November 5th, a talk on identifying AI business problems. All right, let's talk recognition. So Rekognition is the AWS image classification tool. It can be used with both still images and video. At its core, Rekognition provides what most of us probably think of when somebody says an image classifier. We get bounding boxes on an image with labels. It goes beyond just bounding boxes and classifiers on images. Rekognition will give this to you on videos as well, as I mentioned. So we're able to identify objects, events, activities, celebrities, people, all with regards to a timestamp, as well as bounding box location. This kind of analysis of videos is exactly how services like YouTube are able to store videos with so much metadata attached to them, making them highly searchable down to the timestamp. So, all right, let's see what we get out of the box with Rekognition, the kind of API calls that we can expect to make. The first of which is the object scene and concept detection, otherwise known as label detection. This is probably the most straightforward use of Rekognition, capable of classifying objects, scenes, concepts, celebrities, all within our sources. So if the items to be identified are fairly common, chances are we probably get them out of the box. You'll notice categories like pets and animals. We get, everyday items, food and beverages, vehicles, etc. Most business and day-to-day categories have coverage. These are all probably the types of classifiers that one would expect out of the box. There's maybe some less known categories that include, say, damage detection. This has been mostly trained around automotive and real estate. It's capable of determining cracks in walls, broken windows, missing shingles on roofs, leaks, fires, water damage, all that kind of stuff. And then all the typical automotive assessments too, like scratches, scuffs, dents, cracks, breaks, and bending. We get things like prominent landmark detection. We also get facial detection around expressions and emotions. And just as a reminder, I'm just talking about label detection. There's a lot more that we can do around faces with some of Rekognition's other API calls. The detect faces call is really what I'm talking about here. It will find images and analyze them for attributes such as emotion, age, range. It will attempt gender. It will find bounding boxes for facial landmarks like eyes, nose, mouth, etc. Just to clarify, Amazon is pretty clear about the gender classification. It's going to be based on, stereotypical gender traits, and they do provide various warnings about this in their documentation. Anyways, we'll take a closer look at applying this call shortly, as I believe it relates to our case study. But before I move on, I do just want to mention some of the other calls around faces. So the other two kind of prominent ones. One is compare faces. So you essentially would provide two images and a similarity threshold. Based on the threshold, Rekognition just returns to you whether the face is a match or not. The other common one is search by faces or search images by faces, which is used with a custom face index, basically returning to you whether or not the provided face is in the index. I think under the hood, it's pretty much just doing a k-nearest neighbor search against the image. We get text detection, which does exactly what it sounds like. It will detect and recognize both printed and handwritten text in images and videos. If this sounds kind of similar to what TextRack does, you are correct. However, the context and quality of the input is going to be different, and usually the expected results are going to be metadata for tagging and not really like complete extractions like you would expect with TextRack. We have unsafe content detection and detection moderation labels. This will detect explicit, inappropriate, and violent content in images, which in turn can be used to, filter and moderate incoming content. We get celebrity recognition, which boasts having tens of thousands of celebrity images across many different categories, such as politicians, athletes, actors, musicians, streamers. So as long as the index of faces you need is of known public figures, this index may actually alleviate the need to train up your own index at all. Not actually train up, but build your own index, which, as mentioned previously, is something that we can absolutely do. And then lastly, we're provided with custom labels. Custom classifiers can be created to detect objects specific to your use case. So things like logos, products, characters, just about anything that's likely to be outside of the common domain of items, we can train custom classification for. Which more or less, if you've ever used ground truth in AWS SageMaker, Rekognition's custom labeling kind of appears to just be a pre-built ground truth training environment, which is it's a supervised learning environment where you can classify your data for training and a subset of it for testing. Okay, so before I start looking at handing things over, I guess just we'll take kind of a high level look at what working with Rekognition's like API/SDK looks like in Python. And maybe if we have a minute, we'll take a look at the cost model. So let's just step through kind of setting up a simple Python Lambda. First, we just need to do our imports. This is where we'll actually grab our SDK, bot03, and then JSON, because we're in Python, we're probably going to be working with JSON. Next, we define our Lambda handler function where everything can live. We create a Rekognition client using bot03, and then we initialize the bucket and image variable with our file name and bucket location. Obviously, in a larger project or a production project, this would probably be coming from our event, but we're just going to slap it in here. Without much more than that, we're able to write our own Rekognition call now. We can use we'll use the just classic detect label or detect labels. We can point that to our bucket and file, and then some parameters to restrict our results. In this case, what we're using is max labels will limit the labels that we get back, and then min confidence will set the threshold of essentially labels that we're allowed to get back in that pool. And then since we're doing this in a Lambda function, we'll just kind of parse out the label and the confidence scores, and then we can return it as JSON. And more or less, that's kind of it for running it, at least on a single image in an S3 bucket. So let's just take a look at what we get back. Well, the SDK and API are not going to return you an image with boxes superimposed on top. It does essentially return to you everything that you would need to do that programmatically, right? So each item returned in the labels list is an object with a name. So here we picked the car. Confidence is how sure the model is of its classification. The instances are where are essentially the bounding boxes for where you can find the instance within the image. And then parents is a list of usually the broader categories that the item falls under. So we're looking at car, we can see that would be more generally labeled, say, as a vehicle, in the same way that if we were to pick the dog, that would be more broadly labeled as animal or pet. Okay. Apologies. I think we do have a minute for me to cover this. So let's just take a look at pricing. I know it's not the most interesting part. But anyway, so with Rekognition, we do get a free tier. So that means that we have a period that's 12 months from the date of account creation. During this period, you can analyze 1,000 images a month using either group 1 or group 2 API calls. And do notice that is how their pricing works within Rekognition. They kind of have 2 categories for API calls, group 1, group 2. In terms of face indexing, during the free tier, you can store up to 1,000 face vectors. And then for custom training, I think you just get 1,000 user vector objects as well. And then so after the free tier goes away, everything basically becomes you get charged based on invocation. So the cost per invocation actually goes down based on how many millions of images that you're running. So if you are running this at scale, there are price breaks, but you can see that we're talking in the millions. After the first price break, it's like 4 million and 10 million. So and then we haven't talked about it too much here, but the other side of it is streaming video. Basically, the pricing model for streaming video is you get 1 hour of free streaming analysis every month. And then, oh boy, yeah, the pricing on this, it becomes 817 10 thousandths, yeah, of a dollar after that free period ends. So we're talking fractions of a fraction of a penny. But obviously on streaming video, for every minute, it does ultimately add up. All right. So with that, I think it's time to hand things over to Annie so she can talk about using Rekognition on one of our previous hackathon projects. And you just let me know when you want me to click.
All right. So good afternoon, everyone. I'm going to show you a small working example on how to work with Rekognition. Just like David just said, this is Vision AI. It was a group project from the last Metatoad Hackathon. It was developed by me and other 3 team members from here. Next one, please. So our objective here was to create a simple project using Rekognition to identify age and emotions from images. Here on the right is a screenshot of our blog post on the Metatoad website. We actually have a tutorial there on how to do the whole project, and the links for it will be shared in a few minutes if anyone is interested. And about our stack, to create this project, we used a S3 bucket where the images would be stored. We created an API gateway with a Lambda as an API. This Lambda would be used to point recognition to the image in the bucket and return some information to the front end. This was our backend stack mostly. And for the front end, we had a React plus Vite project using mainly TypeScript. And this whole code is also available on our GitHub. So click. So how does it work? I have here on the right the main section of our Lambda code, which is where Rekognition does its job. And since this is in Python, like David said, we'll be using the Bottle3 library to connect to AWS services. So what happens is the user either inputs an image or takes a picture in real time from the app here on the left, and then it calls our Lambda here on the right. On the first step, we add the image to the bucket and give it a unique key. This key is what we'll be using to reference that image in the bucket, so we need to save that. Second step, we call the recognition function detect faces that David told you about before, which is pretty much self-explanatory. We add the bug reference to it and which attributes we would like to get. So for this example, the age range and the emotions of the person in the picture. We could have called other attributes like face details, like it would return that the person is wearing glasses, for example, or the position of some facial feature on the face, like where's the nose, where's the mouth, things like that. And then for our third and fourth steps, after getting the information from Rekognition, we mainly use either confidence or mean to make the results more accurate to the final user. So for the emotion, as you can see, we return the one with the biggest confidence threshold, bigger than 40. And the age, we simply add the lowest and highest age together and get a midpoint between them, basically. Click. And this here is our app working. So like I said before, the user inputs the image is shown on screen, and we get a loading bar while our Lambda is running. Click. And when it finishes, we get the results. So for this lady in the picture, she seems to be on, she seems to have an average between 28 and 32, and she seems to be happy. This is what we get from Rekognition. We can get, this is just a small example. And after that, we can input another image. How many do we want? We can test, see if we can get other emotions or other age ranges, depending on what faces we make, for example. Next. And if you are interested in knowing more about this project, we will be sending some reference links on the chat, blog posts, GitHub, also a link to the application running in Vercel. It will be available only today because after that we might delete the account. So feel free to try it out. Thank you very much.
Awesome. Sweet. Okay, let me steal it back from you. Let's talk about POC funding with AWS and Metaltoad. Okay, so what does this look like? What is a POC? POCs are proof of concepts. They're small projects for customers looking to explore an AWS workload. POCs are meant to determine the feasibility of AWS as a solution and to verify the functionality is kind of as expected. AWS, of course, offers funding because if success is found, Amazon will expect your business. How do you qualify? Well, so first you must work with an AWS partner like Metaltoad. For said partner to qualify, they must be in a validated or higher stage in their partner path, and that path has to relate to the POC. As a side note, Metaltoad is both a software and services partner. Available funding is as follows. You can get up, you do get up to 10% of the first year's annual recurring revenue, or the annualized spend with AWS. This is capped at 25K. There are other programs to explore, though, if we're interested in larger spend. And please note that projects need to be paid out at project completion, but the credits are actually issued up front. And just know the process does require some pre-approval. And I believe in our experience, this can take a couple weeks sometimes. All right, so that includes our overview and case study of Rekognition. I'll pause here if we've got any questions.
Yeah, we have a question here from Marcela. She's asking, how does the program read the emotions from the face? What values does the code read?
So it's not necessarily reading any values. I think under the hood, it's probably, I'm actually going to guess here under the hood, unless you know, Annie. I think it's probably a k-nearest neighbor search, but I'm not entirely sure what's doing the matching. That is, and I let me not bury the lead there. That is one of the powerful pieces behind using a tool like Rekognition is it obscures some of the lower level stuff from us. Sweet. Do we have anything else?
Yeah, does anybody have any other question? You can drop here in the chat or
absolutely drop here in the chat. We can also
raise your hand.
Please, if you want to follow up in Slack too, just let me know.
Exactly.
Cool. Well, I guess if that's kind of all we have right now, let me just leave us here. Thank you so much for attending. If you've got further questions or interested in how Metaltoad might assist you with your LLM, machine learning, or just general AWS needs, I suggest you drop Stacy an email at stacy.gordon@metaltoad.com. She's wonderful, she's knowledgeable, and she'll be super happy to help get you started. Sweet. Thank you so much, everybody.
Thank you.
Thank you.
See you next time.